Hi! In today's video, we're going to be talking about Newton's third and final law of motion. In Newton's third law, we're going to be talking about action and reaction forces. So Newton's third law states that for every action, there is an equal and opposite reaction. So what does this mean in terms of forces? This tells us that all forces happen in force pairs or sets of two. This means that no force can ever take place in isolation. Even if you don't notice that second force, there is a second force that is acting. This means that whenever a force is applied, this is called my action force. And for every action force that is applied, there is a reaction force, which is the force that happens in reaction to that first force. This reaction force is always equal in magnitude. Remember that means the strength of a force, but opposite in direction, applied back to the first object that applied that action force. Let's look at an example. So you may have done this before, maybe in frustration or maybe to sort of make a beat, but think about taking your fist and just slamming it down onto a table as hard as you can, like in the picture you see here. In this instance, we probably can tell pretty clearly that there is an action force that we are applying with our hand onto the table. Now, what you might not have known before this video is that the table is actually applying a force right back. This reaction force is applied by the table onto your hand. The reason I use this example is because if you've never done it, you could do it right now, but probably most of us have. You can think about when you slam your fist as hard as you can onto the table, it actually hurts, or at the very minimum, you can feel it. That gives you the evidence that indeed that table is applying a force back onto your hand. And you'll remember from what we just discussed about Newton's third law that reaction force applied back onto your hand by the table is equal in magnitude, as you see with the force diagram arrows, and is opposite in direction, meaning exactly opposite in the direction of the action force that was applied. So action and reaction forces are the center of Newton's third law and are very, very important in your design and build of both of your devices for your science fair. So remember that your action force is that force that's directly applied by one object onto another object. And we now know that for every action force, there is a reaction force. This is that force that is applied back onto the first object by the second object in reaction to that first action force. Very important to remember again that force is always equal in magnitude, meaning it has the exact same strength, and it is opposite in direction, meaning facing in the opposite direction. So here we can see if you were to come up to a wall and push as hard as you can onto the wall, we know that we would be applying a force or an action force onto the wall with our hands. You now know that wall is actually applying a reaction force back onto your hands. You should be able to know that force again is going to be equal in magnitude. You can see that reflected in the diagram, and opposite in direction. Let's quickly look at a few additional examples of Newton's third law and action-reaction forces. So here we have this girl who looks like she was maybe in the middle of recording a TikTok, perhaps, and somebody chucked a ball at her face. So it's pretty obvious that ball is applying a force onto her face, but you can also see that her face is applying a force back onto that ball. We can tell that a force is being applied because it's causing that ball to accelerate, meaning turn around and come flying back in the opposite direction. Another similar example, we can see this volleyball applying an action force onto her face. Looks a lot more intense in slow motion. And we can see that her face is applying an equal in magnitude, opposite in direction force back onto the ball, again causing that ball to accelerate in the opposite direction. Finally, we have here a crash safety test, and we can see this car come flying up to this wall and applying quite a hefty force onto the wall. That would be my action force. We then know, based on Newton's third law, that that wall is going to apply a force right back to the car, equal in magnitude and opposite in direction, which is pretty obvious to tell because we can see that that car is being damaged pretty severely, which means a force needs to be being applied in order for that to happen. Finally, we'll talk about some applications in the real world of Newton's third law. So the first, super relevant to the theme of our science fair, is in rocket launch. So Newton's third law is the cornerstone of how rocket launches are able to function and be successful. So in any rocket launch, there is a large amount of gas and fuel that will combust or explode, shooting exhaust gas and flames out of the back of the rocket. This exhaust gas applies a huge amount of force onto the surrounding gases underneath the rocket. That's our action force. There's then a reaction force of those gases applied back to the rocket, which is actually what pushes or propels that rocket, allowing it to accelerate and shoot up into the sky and eventually out to space. Another very applicable application of Newton's third law is in seatbelts. So in your car, you know that there is that device that you should put on for safety in the event of an accident. So how does this actually work? So based on Newton's first law, we know that a person sitting in a vehicle in the event of a crash, based on their inertia, will continue trying to move in the direction that the car was going. This would mean flying out of your seat and either crashing into the windshield or flying out of the car. That would be very dangerous and possibly deadly, so we have a seatbelt. So in the event of a crash, when this person attempts to fly forward, they are applying a force onto the seatbelt during the crash, if they have their seatbelt put on. In that case, the seatbelt will apply a reaction force, equal in magnitude and opposite in direction, which is very helpful in this case because the seatbelt applies a force in the opposite direction that the person was attempting to accelerate, stopping them from, again, crashing into the wheel or even worse, flying through the windshield out of the car.